Coming up on this edition of the FRC Open Alliance Show, 6328 Mechanical Advantage is back, and holy cow, their progress has been absolutely outstanding. We got tons of live demos that we'll be showcasing. You got to see how their funnel's working, and for intake and coral, they've added some belts onto that. Their elevator is wicked fast, and we're going to see that demonstrated as well too on screen, so make sure you look out for that. We'll be diving more into their super low clearance they're doing with it, showcasing more on their dev bot, how it's going to translate into their comp bot, taking a look at their climb as well too, and how that's going to be all packaged in, and getting a great update on their software and how everything's coming together with that, including a very interesting choice of computer on their robot as well too. So let's see what their progress is up here on the FRC Open Alliance Show. So welcome back on one of my favorite teams that we have on here on the Open Alliance, 6328 Mechanical Advantage. Hopefully you've been following their incredible build log. It looks like the entire community has, because there's so much going on with what this team has to offer. So welcome back, everybody. If you don't mind, I know we got a couple new faces. Let's introduce everybody. Let us know what you do on the team. We're going to be hopping right into your overview and what you've been working on.
Hi, everyone. My name is Lesia. I'm our vice captain.
My name's Emily, and I'm part of the CAD and manufacturing team.
I'm sorry, I'm the software lead on this team.
I'm Matthew, I'm the CAD lead.
And I'm Advait, and I'm the strategy lead. So today we're going to be going over our bright pink powder-coated kit bot, our dev bot, and our deep climb prototype. So now diving into our dev bot. If you haven't heard already, our dev bot concept, it's super exciting, and we're all really happy about it. And basically what we can do is build a slightly lower fidelity robot than our competition robot, but it's still super capable, and we can get started playing the game earlier in the season while learning a lot. So we have all the same subsystems we're going to have on our competition robot, minus the deep climb, but just a little bit lower fidelity. Obviously, you can see not quite legal for the playing field, but it teaches us a lot about what we can do to make minor improvements on our competition robot design, and we can build it faster, and our driver is a little bit more familiar and everything. So we'll dive right into all the subsystems. So here, we'll start with the algae intake over here. So this obviously deploys up and down to pick up our algae. It's pivoting about two dead axles and two individual dead axles. And something really cool about this subsystem is almost every part is custom made, from the sprockets to the mounting plates and everything. So it's just a pretty interesting subsystem. And we have what we like to call the horse plate with our deployment gearbox. I'll hand it off to Matthew to talk more about, or I'll hand it off to Emily to talk about the hopper.
All right, so I'm super excited to talk about our hopper funnel intake. You know, it has like this open top kind of hopper funnel shape. And what I think is really interesting about our intake mechanism is how much it's evolved in the last few weeks, right? So we started with some inspiration from Big Sky Robotics and their forward intake on day one. And we kind of had that claw plate with the entrapment stars, and the following versions, they kind of built off of that. We just moved the shafts around. We replaced the entrapment stars with belts. We put some compliant wheels on there. But with this year's game and the weight restriction, we tried to look at more passive approaches. So we started using polycarb and bending it instead of using those motorized shafts. But our intake mechanism took a really big pivot when our strategy team decided that it would be worthwhile to implement an intake that can grab the coral from 3 different sides of the robot, right? So at that point, we only had an intake that could receive the coral from the front, but with this kind of open hopper design, we could take it in from 3 sides. So we just kind of flipped our intake on its side, widened it up a little bit, and now this is what our intake looks like. And you can kind of see we kind of kept the most effective parts that we saw throughout the way. So we still have our belts on there, and we still have some curved polycarb, and that's what our funnel looks like now.
Something I want to ask you on this, I know this was something I got asked in your T Delphi build log too, but can you explain why you went with belts as well, not just completely gravity fed on there?
Right. So with the belts, with just gravity on the intake, our coral had some trouble. Like if we were to intake it like this, it would just fall like that, right? But if these motors are spinning, the belts kind of lead the coral right into the end effector really nicely. So I'll pass it off to Matthew to talk about.
Thanks. I'm super hyped to talk about this amazing elevator here. So Suri is going to run it up and down for us. Maybe. Or not. So we geared this elevator pretty aggressively to be able to reach L4 in under half a second. So on the elevator here, we have our static end effector. So on comp, it'll be pivoting to allow us to pick up algae off the reef. But just for DevBot, we took our prototype and we just put it on passively. So this is a 3-stage continuous elevator with a 2-inch spool on the back, geared 4 to 1. So we gear this pretty aggressively to be able to reach all 4 levels of the reef. So yeah, pretty sick. So now Suri can talk about the software. What? Oh, decline? Oh.
All right, so let's talk a little bit about our deep climb prototype. So this is kind of the second type of climb we're trying. This is inspired by 118's EveryBot design. So the way this works is we drive up to the cage, and this hook slides into the cage. The cage is pretty heavy, so it slides on pretty easily with the weight of the cage. And then this then carries the cage right into the robot to help lift it off the ground. And we've gone through a lot of iterations of this deep climb design. A lot of what we focused on is making this prototype as compact and as packaged as possible because, as you can see in our DevBot, we don't have a lot of space left. So what we've been focusing on is finding ways to stow the arm. So instead of having just one tube holding up our pivot, we have 2 tubes so the arm during a match can stow between. So on our DevBot, this will go right under the hopper, and when we want to climb, this will go up and then pull the cage into itself. We also changed it so it's chain driven, also a lot because of packaging reasons. And yeah, we're still continuing to work on it. Right now we're working on packaging it even more and then adding a more higher fidelity gearbox to the climber.
So in order to package that into like kind of where your DevBot is right now, is your hopper going to have to articulate then as well too, or how does that work when you want to deploy that climber essentially?
Yeah, so we'll have, our competition robot is going to look a little bit different, obviously, but we are going to just package it a little bit more. So we are going to share this shaft of our hopper, most likely, with our climber. So we'll kind of stow underneath, and then it would go up at the end of the match. All right. Now Sarah's going to talk about software.
So software's been up to a lot in the past 3 weeks of build season. So I guess in the past week, we pretty much finished up and posted what is close to be our final vision solution for 2025. Most notably being that we've changed from using, or we're now using the Boslers this year, which are a bit more, which are faster than our older cameras. So they run at about 100 FPS monochrome, and we have color versions of these which run about 50 FPS. As well as that, we switched up with a coprocessor we're using this year. So we got the Apple Mac Mini M4 on our robot now, if you want a logo. Yeah.
So like literally that whole thing's gonna be on the robot?
Yeah, just one of these.
That's amazing, by the way.
Yeah, and so we done a lot of stress testing with that. I think when we first thought about doing it, like in November-ish, we had one Mac Mini up to running 6 able time detection pipelines, and we were able to get, well, actually 10, and we were able to get 50 FPS on all of them. And so that's pretty much sealed it for us. Or
I just gotta add, like, whose idea was that, or what was the inspiration behind even using that?
well, I think there's been teams in the past who have tried to use. I think some team did use the Mac Mini M2, but we we saw the price of the M4 come down, and we were like, okay. This is not my fault. Yeah. Okay. Yeah. So we did see some buzz online about the M2 Mac Mini, and we are aware of the price of the M4, and we realized it was within our budget and within our constraints resource wise. So we decided to make the choice like that. As well as that, with the kind of update to the architecture on the robot or compbot, software has been busy, has been up in the water. with Coteray. Yeah, so Matthew, do you want to demonstrate the failure zones of the superstructure?
Should be avoided.
These are only some of the great things to get off a live demo. So I really do appreciate everything that's been all the attempts that have been made. We'll say the showcase what this is. Very cool on that. Anything else from software you want to dive into?
Yeah, so one of the cool things we'll be posting up in the few days is our whole control screen with the superstructure, especially with it being so complex this year, with of course having the linear mechanism and the rotating pivot, as well as the slamming intake and the addition of having an algae stored on the end vector as well. So that was pretty fun to do, or not really, but it's fun.
If you don't mind, I'd like
Thank
to go
you.
back to the elevator a little bit from the mechanical side of things. I mean, when we showed that thing deploy, I mean, that was a lot of energy, coming out right away, a lot of momentum and stuff when that comes up right away. How are you making sure that like you're not being tippy when you're, sending up that much weight that quickly, that sort of thing?
Yeah, so that CG and managing our CG in this game is a big priority for us. So DevBot right here is 26 by 26, but on comp we're going to bump that up to 28 by 28 just for add stability. And then we counteract that with having the battery low in the back of the robot this year. And then this year we also dropped our belly pan. On Dev we have 1x1s, but on comp we'll use the SDS lowering blocks. So all that allows us to lower CG. And then in terms of the actual elevator itself, a big priority for us is super rigid mounting of the tubes and being super rigid within it. So making sure everything's boxed in properly and super rigid. That way you're able to send it up full force into the hard stops without having to worry about anything.
And how high off the ground is that drivetrain? I mean, that just looks super, super low.
Yeah, so we have 0.75 from the tube to the ground with the 1/8 inch belly pan.
So we've
So,
seen the pink the pink kit bot, right? We got the gold dev bot, right? Are we going full blue on the account bot, or what's the plan from that standpoint?
Yeah, we'll stick to our usual blue and black color scheme.
Love it. So, okay. Anything else that you want to highlight or cover or go through? I mean, like I said, there's so much for us to explore on this. One of the things I know we're not going to dive too deep into on this, by the way, too, is you got to check out their posts on scouting and how their apps are working and that sort of thing, too. So make sure you check that out. But anything else you want to highlight or cover?
No, I don't think so, but thank you.
Yeah, 6328. This looks awesome, and we can't wait to see your continued progress as well, too. I know many of you are following the Build blog, but if you're not, go check it out on Cheap Delphi, see what's happening for that, and so many great posts coming up. So thanks a lot, everybody, and best of luck the rest of the way.